Shivani Trivedi, Assistant Professor in Computer Science and Engineering Department. Today we will going to discuss very interesting topic, that is programmable logic array. This is a part of digital electronics. These are the outline that we are going to cover. Introduction to PLA, programmable logic array, example of PLA so that you can easily understand what is PLA, and the circuit implementation of that example. Now, what is PLA? Programmable logic array is a fixed architecture device. This word is fixed architecture logic device. This is sometimes also known as PLD. PLD, that is programmable logic device with programmable AND gates followed by programmable OR gate. Don't get confused that here programmable means that you are doing in C, C++, Java. This is different. So we will understand PLA by taking one example. So first step to make any combinational circuit using PLA, the first step is to make the truth table. You have to make the truth table. In this example, I take this truth table. Truth table is random. A, B, C are the inputs and Y1 and Y2 are the outputs. This is the random truth table of any logical circuits, so that you can easily understand what do you mean by PLA. I am taking one random example. After that, after making the truth table, in step 2, you have to minimize SOP. SOP is sum of product. So there are two output functions, Y1 and Y2. You have to see where Y1 is 1. Y1 is 1 here, here and here. According to this Y1, you have to see the corresponding input, that where input is high and where it is low. For Y1, A, B bar, C bar. This one, A, B bar, C bar. And for this, plus A, B bar, C. And for this, A, B, C. So this is the SOP, but this is not minimized SOP. So by using Boolean algebra law, we are going to minimize this expression. From these two minterms, I am taking AC as common, and we will get B plus B bar. What is B plus B bar? B plus B bar is 1. So we are left with AB bar, C bar plus AC. Again, I am going to take A as common. We are getting B bar, C bar plus C. Now in this expression, I am going to apply distributive law, which is A plus BC equals to A plus B into A plus C. So Y1 minimized expression is A, B bar plus C, that is AB bar plus AC. Similarly for Y2, from the truth table, we see where Y2 is high. Y2 is high here, here and here. According to this, we have to see the inputs. For this, input is A bar BC plus, for this, A B bar C, and for this, ABC. Again, from these two minterms, I am taking AC as common because we want a minimized expression. AC as common, we are left with B plus B bar. B plus B bar is 1. A bar BC plus AC. So again I am taking C as common. A bar B plus A. Here we are applying the distributive law. So we are left with AC A bar. A plus A bar is 1. A plus B. So we are left with A plus B. So AC plus BC is your minimized expression for Y2. So final expression I am writing Y1 equal to AB bar plus AC and Y2 equals to AC plus BC. Now in step 3. In step 3, we have to calculate for the circuit implementation how many input buffer we have to. What is input buffer? Basically, input buffer is a combination of NOT gate which are giving variable in both complemented and uncomplemented form. So, there is one input and two outputs. Suppose X is the variable. So, from this input buffer, we are getting both output in complemented and uncomplemented form. This is equivalent to, suppose I am taking one NOT gate. NOT gate has one input and one output. This is input and this is output 1 and this is output 2. Suppose X is the input. Here we are getting X bar and from there X bar ka bhi X bar ka whole bar equal to X. So here we are getting both variable in complemented and uncomplemented form. This is equivalent to this input buffer. So how many input buffer we require for the PLA implementation? It depends on number of variables. And in our equation, we have three variables, A, B, C. So number of input buffers equals to 3. Now next, number of programmable AND gates. You have to see how many number of minterms are there. You have to see how many number of minterms. And please remember, minterms should be distinct. It should not be repeated. You have to see in your output expression that how many minterms are there. So this is our final expression. AB bar plus A, B bar plus AC, AC plus BC. So total you are seeing here are 4 minterms. But in this AC is repeating. So I am already told you that you have to take distinct minterms. So total we have AB bar, AC and BC. So total we have 3 programmable AND gates. Now next, number of programmable OR gates. It is equal to number of output function. So here there are 2 output function Y1 and Y2. So total number of programmable OR gate is equal to 2. Now we proceed further. In next step, we have to make the circuit. So how many number of NOT input buffer? Already discussed. We require 3 input buffer. This one for A. This one for B. And this one for C. And now, how many AND gate we have to require? We require 3 AND gate for 3 distinct minterms. 3 AND gates. This single line denotes each minterms. How many OR gate? 2 OR gate. One for Y1 and another for Y2. So next, how we have to connect this? So first of all, I am writing final expression, final SOP expression, y1 equal to AB bar plus AC. Y1 equal to AB bar plus AC. And Y2 equals to AC plus BC. Y2 equal to AC plus BC. Suppose this is AB bar. This single line is for AB bar. This is for AC and this is for BC. So A. For here we are marking the cross. Cross means this is connected to this single line. B bar. B bar. Because this input buffer will give you variable in both complemented and uncomplemented form. A, here we are getting A, here we are getting A bar. So similarly, here we are getting B, here we are getting B bar, C, C bar. So for A, B bar, we are marking the cross here, A, and for B bar, here we are marking the cross for B bar from here. For AC, we connect this A. For C, we are marking the cross here. For BC, we are marking the cross here. And for C, now to make the output expression, AB bar plus AC. This is AB bar plus AC. You will get the Y1. For Y2, AC plus BC. You will get the Y2. So this is the final circuit implementation for our example, for which we are making the truth table. Similarly, you can make any combinational circuit using PLA. Already you have studied many combinational circuit and you make this using the conventional logic circuit. But this PLA is more portable than the conventional logic gates. So you can, this PLA are getting in the form of chips available in the market. You can program them easily according to your requirements and use them to make any logic circuits. These are the references that you can follow for the studying about the PLA. Thank you.